Hi to the Ho students, Mr. Kaczynski with you, and I'm going to go over solving linear systems using substitution. Okay, so this is a system of equations right here, these two equations together. They're two straight lines. They'd be tough for us to graph on a graphing calculator because this one's not solved for y. So what we're going to do is use an algebraic method to solve this. So what it says is that x equals 4. X and 4 are the same thing. So if that's the case, I can put that value of 4 right in there for x. All right, so let's do that. Let's go -7 times the x value, which is 4, plus 4y equals 8. Okay, so that's an equation I can solve and figure out what y is. Obviously, I can do -7 times 4 is -28. I can then add 28 to both sides. 8 plus 28 is 36. And then I can divide both sides by 4, and I get that y is 9. Okay, and we already know what x is. X is 4. So that means our solution here is going to be color-coded here, 4 and 9. And the last thing I'll do is check that answer. So we already know x is 4. That's flat out given to us. So I think what I'll do is I'll go to the calculator. I'll do -7 times the x value, which we already know is -28, plus 4 times the y value, which we just figured out to be 9. That does equal 8, just like it does over here. So I know I've got the right answer. All right, substitution here. So y is equal to 3x minus 10. Y is also equal to 2x minus 5. This one might be a little bit easier to graph. Maybe we'll check our answer through a graphing method, but I'm going to use substitution. This is y. So that means I can replace y with that value. So that's what I'm going to do. I'm going to say 3x minus 10 equals 2x minus 5. At this point, I'm going to subtract 2x from both sides. 3x minus 2x would give me x. (2x minus 2x would just leave me with a -5 over here. Then I'm going to add 10 to both sides. -5 plus 10 is 5. Okay, so now I know what x is. I'll start writing my answer here. Yeah. How would I switch colors here? Now I just need to figure out what y is. Okay, well, y is 3x minus 10, or y is 2x minus 5. So let's go like this. Y equals 3 times x minus 10. Three times 5 is 15. And 15 minus 10 is 5. So it seems like our answer should be, what did we get for x? We got 5 for x. And we got 5 for y. Okay, they both happen to be the same thing. Well, we're going to check our answer first. So 3 times x minus 10, that should equal y. And also 2 times x minus 5 should equal y. Also, if I go to the y equals function on my calculator, I could put 3x minus 10 in. And I could put 2x minus 5 in. Go to the table, go to 5, and that is where the outputs are the same. I could also go to the graph. And I could go to the trace function. 5, enter, and that's where they're the same. That's where the two lines intersect. Let's do another. Using substitution. So I'm going to take this piece right here and substitute it in for y. So I'm going to do x minus 6, that's y, equals 9x plus 10. And at this point, you got to just be good at solving equations. I'm going to solve this one a little bit differently. I'm going to subtract x from both sides. So it's gone from the left, and 9x minus x is 8x. Then I'm going to subtract 10 from both sides. So the 10 disappears from the right, and negative 6 minus 10 is negative 16. And then I'm going to divide both sides by 8, and that gives me negative 2. So now I know what x is, and I just got to figure out what y is. But I know y is x minus 6. It's also 9x plus 10, but you can plug that x value into either equation. So I'm going to do negative 2, that's x, minus 6. So y is negative 8. So again, our x value seems to be negative 2. I'll check my math here. And my y value seems to be negative 8. Pretty confident I did everything right, so I'll put a box around it, but I'm still going to check my math. Let's go x, negative 2, minus 6, and that should give me my y value. I'm also going to do 9x plus 10. 9 times x plus 10. That should also give me the same y value, negative 8. It does. I can also use the table function to check my math. We think the answer is negative 2. There's the negative 8s. I can use the graph function. Go to trace negative 2, and that's the point where the two lines intersect each other. So got it. But we're trying to concentrate on this substitution idea. So first, find out what x is by substituting. Okay. Then find out what y is. Then you'll have your answer. Over here, we found x. Then we found y. We used x to find y, and we had our answer. Ooh, this one looks a lot tougher, doesn't it? All right. Here's the tricky part with this one, is that we need to actually figure out what one of the variables is. We don't always have to substitute for x, or for y rather. Here's what I'm going to do. I'm going to take this equation and kind of just manipulate it a little bit. I'm going to make it negative 16 minus 3y by just subtracting 3y from both sides. This is kind of more advanced, okay? Now that I know what x is, I can put it into that equation right there. That's what I'm going to do. I'm going to do negative 3 times x, which I think is negative, not I think, I know, it's negative 16 minus 3y. Minus 3y equals 18. So do you see how I got this equation solved for x, and then I took the blue expression, plugged it into the other equation. And now I'm going to solve this. I'm actually going to figure out what y is first. All right, so negative 3 times negative 16 is 48. And negative 3 times negative 3y is 9y. That's called distributive property. Now I'm going to combine like terms. The 9y minus 3y is 6y. Then I'm going to subtract 48 from both sides. 18 minus 48, what's that, negative 30? You can use a calculator, obviously. And then I'm going to divide both sides by 6. Negative 30 divided by 6 is negative 5, or divided by positive 6 is negative 5. Now that I know what, I'll move this stuff down a little bit here, give myself some room. Now that I know what y is, I can use y to figure out what x is. So I'm going to come back up here to this blue equation, and I'm going to say, okay, x is negative 16 minus 3 times y. Y is negative 5. So that would be negative 16 plus 15, because negative 3 times negative 5 is 15. So x is negative 1. All right, let's check. I think that our solution here is negative 1 for x and negative 5 for y. Obviously, you got to be really good at solving equations to pull this stuff off. Let's try it here. Let's go back to the main page here. Let's go negative 3 times x, negative 1, minus 3 times y, negative 5, and this should equal 18. It does. Okay, now I'm going to go to the second equation, x, which is negative 1, plus 3 times y, which is negative 5, and this should equal negative 16. It does. Can't really use the table function this time because they're not in slope-intercept form. One more. Let's do it. I think what I'm going to do this time, I'm looking at this positive y right here. If I just get that by itself, if I just add x to both sides of this equation, I'd get negative 8 plus x. And then now I know that y is negative 8 plus x. So I'm going to solve this equation. Here we go. Negative 5x minus 7 times y, which is negative 8 plus x, equals negative 16. Got to solve this equation, figure out what x is. Man, there's some stuff we got to be able to know how to do here. Be able to solve some equations. Negative 5x, negative 7 times negative 8 is 56. Negative 7 times x is negative 7x. That's distributive property. Now I can combine like terms. Negative 5x and negative 7x makes negative 12x. Now I can subtract 56 from both sides. Negative 16 minus 56. That's negative 72. And then I can divide both sides by 12. Divided by 12, it's negative 6. So now I know what x is. Now I'm just going to come back up here to this blue equation. I'm going to figure out what y is. It's negative 8 plus x. Negative 8 plus negative 6 is negative 14. All right, so I got my answer. My answer is negative 6 for x and negative 14 for y. Obviously, I'm going to check that answer algebraically. Calculator is the easiest way to do that. So negative x plus y should equal negative 8. And negative 5x minus 7 times y should equal negative 16. Uh-oh. I did something wrong, didn't I? Let's find out. Let's see, I added x to both sides, plugged in, negative 5 times x, negative 7 times y equals negative 16. I did negative 7 times negative 8. Negative 7 times negative 8 is positive 56. I combined like terms. Negative 5x and negative 7x makes negative 12x. I subtracted 56 from both sides. Negative 16 minus 56, negative 72. And then I divided by negative 12. Oh, yeah, that should have been positive 6. There's my issue. So that's positive 6, which is going to change this to positive 6, which is going to change my y value to negative 2. All right, so let's get rid of that. Then we'll recheck our answer. This is why we check answers. Negative 2. All right, so start over. Negative x plus y. This should equal negative 8. It obviously does. And then negative 5 times x minus 7 times y. This should equal negative 16. Got it. All right, so you saw me make a mistake, and you saw me catch it, and you saw me try and go back and fix it. All right, lots of work to show, lots of equations to solve. Good luck.